analysis of the numerical analysis, and in the last class we are discussed the application which is related to the Stirling formula. Now what they asked me in that question, they asked that just we have to solve this application by using two formulas. One is Stirling and another one is Bessel. Okay, now here I am going to take the Bessel formula. What is the formula for the Bessel? Just now I gave now. So write down the Bessel formula. Now here I am writing. Bessel formula is yp is equal to, first of all, y naught, next plus p into del y naught. Okay, next plus p into p minus 1 by 2 factorial of mean del square y minus 1 plus del square y naught by 2 plus p into p minus 1 into p minus 1 by 2 by 3 factorial into del cube, square is finished now, so cube y minus 1 plus next value p plus 1 into p minus 1 into p minus 2 by 4 factorial. Only for this one we will get 1 by 2 and for the remaining it will be same, and of del power 4 y minus 1 is finished now, so y, of course here it is finished. Next again we will get that one, y minus 1 plus del power 4 y minus 2. For the next one it will be increases by 2 plus so on. Okay, so now here I have that all the values. Now simply I have to take the first of all p value. So before going to that, what is h here? Put a side heading mark, Bessel's formula, and what is h here? 0.62 minus 0.61 is 0.01 h value. Next what we have to find? We have to find that the value of p also. P will be same now because x equal to x naught plus ph. Therefore what is x? 0.644 equal to 0.64. X naught is 64 now plus p into h 0.01. Therefore p is equal to 0.4. Just now we calculated for Stirling. Next here what we have to take? We have to consider yp. Yp means e power 0.644. Okay. Now I am taking yp as it is. Next y naught. So this is x naught and this is y naught. Next for Bessel what we have to go? We have to take that first individual value. So individual value and that to downwards. So it is this one. Next mean. I mean two values. Next again only one value. Next again two values. Okay, like this we have to. So now here y naught is 1.896481 plus p into del y naught, p is 0.4 into del y naught is 0.019060. Okay, plus p into 0.4 into 0.4 minus 1, that is minus 0.6 by 2 factorial means 2 into mean 0.000189 plus 0.000191 by 2. Next p into p is 0.4, p minus 1 is minus 0.6 and p 0.4 minus 1 by 2, that is 0.5 by 3 factorial means 6. Next del cube y minus 1 is into 0.5 zeros. 1, 2, 3, 4, 5 zeros 2. Okay. Next this is finished. Next plus p plus 1. 0.4 plus 1, that is 1.4 into 0.4 into minus 0.6 into 0.4 minus 2. So minus 1.6 divided by 4 factorial means 24 into the sum of these two 0.000002 plus 0.000001 by 2. Okay, so now here we have to take the calci. Now 1.8964, calculate it more fast. 0.4 into 0.1, 0.019060. What you have got? 0.007624. Next, here what I am doing is, listen carefully, 0.4 into 0.6 divided by 2. 0.12, actually we will get minus, okay, and open bracket, sorry, 0.12, and here what we have, divided by 2. So divided by 2, 0.06 into open bracket 0.000189 plus 0.000191, close the bracket. It is nothing but minus 0.0000, 4 zeros mark. Okay, next, minus into minus, here we will get that plus. Now write down 0.4 into 0.6 into 0.1 equal to, divided by 6 again, into 0.50 mark 2. Now it is nothing but 0.8 zeros, 3, 4, 5, 6, 7, 8. 8 zeros, 8. Right? Next, minus into minus, here also we will get plus 1.4 into 0.4 into 0.6 into 1.6 divided by 24 mark, and divided by 2 again into 0.50 now, so simply 0.0112 we got into 0.503. Now 0.1 2 3 4 5 6 7 zeros, 3 3 6. Okay, so now just take the addition. 1.896481 plus 0.007624 minus 0.0000228 plus 0.803 4 5 6 7 8 8 plus 0. How many zeros? 7 zeros. 3, yeah, 4 5 6 7 3 3 6. It is again 1.904082242. We will get the same answer. Obviously we have to get. Okay, so this is nothing but the required answer. And how many digits they are taking? 6 now, so it is enough to take. So like this you have to calculate the applications related to the Bessel's and Schilling. Okay, now I am giving the same application homework but same, you have to take the Schilling formula, you have to take the Bessel formula, but you have to take the value of the x. I am taking that x is equal to 0.644 now, and here x is equal to 0.638. Now write down from the above problem, otherwise from the table of above problem, find the value of e power x. Find the value of e power x. Find the value of e power x when x equal to 0.638. This is x. Now what will be the x naught? 0.63. Okay, so you have to take these values and calculate p. The next use Bessel formula and Schilling formula. That's it. Okay. Next, one more application. Can I give the answer, ma'am? So the answer from the Bessel and from the Schilling both are same. 1.892692. Okay. Next problem. The values of x and e power minus x. The values of x and e power minus x are given in the following table. are given in the following table. Find the value of e power minus x. Find the value of e power minus x when x equal to 1.7475. Okay, so here they didn't mention any method, so that is your wish. You can use Stirling, or you can use like a forward, Gauss forward, or Gauss backward, or Newton forward, or Newton backward, whatever. So here we are discussing the Stirling and Bessel's now, so you can use that one. And here I am giving the table. Now x values I am taking and e power minus x ma. Write down 1.72, 1.73, 1.74, 1.75, 1.76, 1.77, 1.78, 0.1790661749, 1479. Write as it is. Next you have to calculate del square, del cube, del power 4 and so on. Next you can use that any formula. Which one you are feeling easy, then you can use that one. Maybe Stirling or Bessel's, whatever it is. Okay. Next. Put aside heading Lagrange's interpolation formula. Lagrange's interpolation formula. It is a very easy one, and of course important also. Okay, now write down ma. Lagrange's 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 interpolation formula. Now write down. Let y of x be a continuous and differentiable function in the interval over interval a comma b, given the n plus 1 points as x0 comma y0, x1 comma y1, x2 comma y2 and so on. What they said, n plus 1. So we are taking that including initial value. That's why xn comma yn are the points. Where the values of x need not necessarily to find a polynomial of degree n. The Lagrange's interpolation is denoted with Ln of x, such that Ln of xi is equal to simply it is y of xi, which is equal to yi. Box it. Now you can change that n equal to 1, 2, 3 and I equal to 1, 2, 3 and so on. Of course, I values are starts from 0 to n. Okay. Now write down. The equation of a straight line. Next line. The equation of a straight line passing through the 2 points x0 comma y0 and x1 comma y1 such a polynomial is L1 of x, okay? L1 of x, and the value of L1 of x is, remember L1 of x, first of all we are taking now, so I am going to say how we have to take the Lagrange's polynomial formula. So here how many points we have? 2 points, x naught, y naught. So first of all here we have to take that, we have to ignore x naught. That means in the numerator you have to take only x minus x1. Okay, by already we discussed in the previous topic. Now what we ignored? X naught. So now in the denominator x naught minus x1 into what is the first value? That is nothing but y naught. So here y naught plus here we have another point now. So that's why x minus, here we have to ignore x1. That means x minus x naught by, in the denominator we have to take x1 minus x naught into y naught. Box it. This is the formula. Okay, and it is also denoted with L1 of x is equal to small l naught. That means this value, small l naught means x minus x1 by x naught minus y naught plus L1 y naught is the required formula. And additionally here we can write it as nothing but summation. What I can take this L, here the value is changing now, so Li yi, where I runs from 0 to 1. That's it. Okay. Now here this is the formula where L naught is equal to x minus x1 by x naught minus x1. And what is L1? X minus x naught by x1 minus x naught. Okay. So this is the important formula you have to remember, and you can write like this also. Okay. Next. From the above, the value of L naught of x naught is equal to 1 and L naught of x1 is equal to 0. So here what they are saying is L naught. If I put x naught, that means in place of x. Okay, here this is L naught no more. So when it is nothing but L naught of x, which is equal to this one. If I put x equal to x naught minus x1, x naught minus x1, both will be cancelled and what we get? 1. And if I will take x equal to x1 minus x1, 0. 0 by something is 0. Otherwise I will give here x naught minus x1 by x naught minus x1, which is equal to 1. x1 minus x1 by x naught minus x1. This is 0. Okay. Now similarly L1 of x naught minus x naught by x1 minus x naught is 0. L1 of x1 is x1 minus x naught by x1 minus x naught, which is equal to 1. Okay. Therefore it can be written as Li of xj. Li of xj. See here, if it is equal to this value 0, 0, then we are getting 1. If it is not equal, then 0. If it is not equal, 0. So that's why here 1 and 0. So if I is equal to j, it is 1, and if I is not equal to j, we are getting some 0. Okay. Next. Therefore, by substituting the value of Lixj, then we get L1 of x. Then we get L1 of x. That is nothing but L0 y0 plus L1 y1. Otherwise, only here what we have to consider? Then L0 x0 plus L0 x1. Directly I am taking that simply. this one and this one, only the addition. Then x minus x1 by x0 minus x1 plus x minus x0 by x1 minus x0 is equal to 1 for I is equal to j. Condition apply అవుతుందండి. Okay. Similarly, so ఇదంతా పక్కన పెట్టండి. Okay. Similarly, L2 of x. Similarly, L2 of x is, so now here for L1 we have to take 2 points, and for L2 x0 y0, x1 y1, x2 y2. That means L2 of x is equal to, for first one we have to ignore x0 and the remaining values are x minus x1 into x minus x2 by here x0 we ignore now, so x0 minus x1, x0 minus x2 into y0. Okay, the next plus, next we have to ignore x1, that means x minus x0 into x minus x2 by x1 minus x0, x1 minus x2 into y1 plus next third x2 we have to ignore, x minus x0 into x minus x1 by x2 minus x0. We ignored the x2 value now, that's why x2 minus x0, x2 minus x1 into y2. This is nothing but the value of the L2 of x. Similarly, otherwise in generally, the Lagrange's interpolation formula is given as for and so on xn by n, right, as it is given as ln of x is equal to x minus x1 into x minus x2 and so on. What is the last one? X minus xn, and in the denominator x0 minus x1, x0 minus x2 and so on, x0 minus xn. Only first term, here we have only 2 values now, so when we have n we will get n into y0 plus x minus x0. Now we have to miss x1, now x minus x2 and so on, x minus xn by x1 minus x0, x1 minus x2, so on, x1 minus xn into y1 plus x minus x0. Now this value we have to skip, x2, so on, x minus xn, and in the denominator x2 minus x0, x2 minus x1 and so on, x2 minus xn into y2 plus so on is the required formula for Lagrange's interpolation. Okay, so in the next class I will discuss the applications of the Lagranges, and after that we have that one concept, that is divided difference and the properties. In that we have only 2 methods now, so by discussing those 2 we will finish the second unit also. Okay, so again we will meet in the next class. I hope it is clear to you. Please be perfect with our formulas. If you remember the formulas easily, then simply you will get 100 by 100 out of 100 by 100 in this paper, because mid marks are totally depends upon you, and of course it is a very easy thing to you, but coming to the semester you can score 80 out of 80 also. So be prepared well, and I hope you will, and if you get any doubt then please ask me. Thank you everyone.